Today we want to talk about vertex form of the parabola. We want to look at the form, the function, or y is equal to some constant a equals x minus some other constant h squared plus k. We want to talk about why does the vertex form give you the shape that it gives you, and why does it tell you where the vertex is. So let's look at what we mean by that by actually graphing it. Right here you can see we have the vertex form of the parabola. A x minus h squared plus k, and a is 1, h and k are both 0. And right now you can see that that gives you the vertex at 0. We're going to ignore a till later, but let's talk about what that meant when we said the vertex is hk. If I change h to 4, notice the vertex, the x value of the vertex has moved over to 4. If I change k to minus 2, notice the y value of the vertex has moved down to minus 2, so the vertex is now at hk for negative 2. Now we're going to work through this slowly and think about why does this happen. The first thing we want to do is think about why do we get this nice symmetric shape around the vertex. Well, let's answer that question by setting h and k to 0, and that will make it simpler for us to see what's going on. If h and k are 0 and a is 1, we just have this nice simple form y equals x squared, or f of x equals x squared. Let's look at what happens and try to do some reasoning about what we see there. So, when we look back at our screen, we're going to see our parabola. We'll switch our parabolas here. We're going to see our parabola has this nice simple shape, and let's think of it with just a little arithmetic. If x is 0 and 0 squared gives you 0, then you know 0, 0 has to be a point on the graph. So that's pretty straightforward. Now let's think about what happens when you have a number or the negative of that number, and we can demonstrate that here. C is currently set to 2.5. Let's switch it down to 1 where it's easier to see. If I say 1 squared gives me 1. If I say negative 1 squared, negative 1 squared, negative times negative is positive, also gives me 1. What we're going to see in this nice simple form is the negative squared gives us the same answer as the positive squared. So if I put 2 in, 2 squared is 4, negative 2 times negative 2, negative times negative positive, negative 2 is also 4. So the symmetry has to arise because a negative value will be the same as the equivalent positive value, the absolute value of that. If I went up to 3, 3 squared would give me 9, which would be off the top here, and so on. My negative values, 3 squared gives me 9, negative 3 squared also gives me 9. The negative values have to look the same as the positive values in terms of the y value they're generating. So our reasoning tells us that if we have this nice simple form, we can contrast a negative c to a positive c by recognizing that they will give the same value. That gives us our symmetry. And just for clarity, what is in the middle of our symmetry between negative and positive is 0. So in this nice simple form, 0 is the middle of the symmetry because everything on the left is negative and everything on the right is positive. They have to give the same answer. So our vertex in the simple form right here, 0, 0, is the center of this symmetry. Now let's do the same reasoning going back to bringing h back into equation. We're going to ignore a and k for right now and just bring the h back into the equation. So what happens at x minus h? Well, to test the symmetry, h plus c, any number, will be to the right side of the h, and h minus c will be to the left side of the h. So our equation looks like this. Let's just test that out. And when we do that, let's do it, let's take a specific example. So if we take a specific example, what happens if we say h is going to be 3 for our specific example. So we're going to work with that. And let's say c is 1. So h plus c, 3 plus 1 equals 4. H minus c, 3 minus 1 is 2. So now let's work that into the equation and compare the two of them. So I'm going to say y equals 4 minus 3 squared. Well, 4 minus 3 is 1. I'm looking at y equals 1 squared, and of course that is 1. Let's look at the other side. Y equals 2. 2 minus 3 squared. And now in this example, y equals 2 minus 3 is negative 1. Negative 1 squared. Well, a negative squared is a positive. We get the same answer from the one side of the vertex as the other side of the vertex. So going down from h minus c is the same as going up from h plus c. Now let's look at what we just said on the graph. If we change our h to 3 and leave everything else alone, right here we have our vertex 3, 0, and going down 1, well, that's approximately down 1, gives us, that's approximately down, going down 1, 2 gives us 1. What happens if we go up 1? Well, going up 1 also gives us 1. Now we can follow that through. What happens if instead we go up 2? If we go up 2, that's going to give us 4, because 3 plus 2 is 5, and squaring that's giving us 4. What happens if we go down 2? 3 minus 2 is 1, and that's going to give us this 4 right here. Okay, so with those things shown, let's now move the k into the process. We saw that the symmetry has to be around the h. What does the k do to our equation? Let's bring that back in and notice that x does not affect k. K stands alone, so whatever you get from the first part of the equation stays the same regardless of what you just did. K is going to just add to whatever you just did. So take whatever you just did with the h and the x and the a and add 1 to it, and it's going to move up. It's going to be whatever you just saw plus 1. Subtract, say, 2 from it. It's going to be whatever you just saw minus 2. So that k, it's real easy to see what k does. K moves it up and down. And we just showed you how the h logically moves it side to side because inside the parentheses, let's say this another way, if I put h inside the parentheses, h minus h gives 0. That's where the vertex in the simple form occurs. Now the only thing left that we didn't talk about is the a value. A is being multiplied. You might compare this to a line and think about slope. And to think about slope, let's draw a little slope triangle in starting from the vertex. So you can see a slope triangle drawn right there. The way I'm doing this demonstration, I'll give you a hint, you always draw the slope triangle from the vertex and you always go over 1. That'll be some other lesson at some other time. But notice what we have here. We have slope drawn in. Now remember what happened when you had a line. If you increase the value of the thing being multiplied with a line we called that m, it got steeper. Let's go up and make it steeper. Well, doesn't that look twice as steep as what we just saw? Well, might be easier if we go back to 0, and then it's easier to see how steep it is. So when we had a as 1, it went from 0 up to 1. That's a slope of 1. When we have a equals 2, it went from 0 over 1 and up 2. That's a slope of 2. When we have a equals 3, it goes from 0 over 1 up 3. That's a slope of 3. And of course, what happens if we switch a to a negative number? We can go from 0 over 1 and down 1. Our slope is negative 1. Again, what we just demonstrated, the reasoning we just used, only works if you start from the vertex and go over 1. Again, that'll be a discussion for another time. So we've made sense of everything. H has to, the form has to be symmetrical because a square gives the same thing on the right and left. Positive gives you the same thing as a negative squared. H has to be the center of the symmetry because when x is h, that is 0, and then anything on the other side is a negative, and anything on the right side is a positive. So h becomes the new center. K doesn't change anything except move it up if it's positive and down if it's negative. And A, being multiplied, is just like slope, just like you saw with a line. So it all makes sense if you stop and think about how each piece is working. And how did we make sense of how each piece was working? Remember, a square, because positive is the same as negative, gives you symmetry. Look around that symmetry to what is on the right side of the symmetry and compare it to what's on the left side of the symmetry. Our new center, once we put h in, is on the right and the left. And then, of course, the k simply moves it up and down, and a changes the slope. And everything follows nice and logically. Slope, left and right motion, giving you the symmetry, up and down motion. And that's the end of vertex form.